1 billion data points, enough to map the entire planet in microscopic detail. Yet for decades, cities grew blind. Picture a city struggling to breathe, its growth choked by a fundamental lack of understanding of its own complex anatomy. Before 3D aerial mapping, urban planning relied on flat, two-dimensional surveys that took weeks for just one city block, missing vital context. Engineers literally couldn't see the whole picture. These outdated maps could miss up to 80% of critical urban features. This resulted in project failures, costly overruns, and citizens quite literally tripping over their own city's plans. It felt like assembling furniture with only a blurry photograph. Now, 3D aerial mapping is changing that narrative. A single 30-minute flight can cover several square miles, with systems emitting 500,000 laser pulses every second. They accurately measure distances down to 2 centimeters, precise enough to spot a snail on a leaf. Cities are becoming digital twins, where we can simulate everything from traffic flow to emergency response with unprecedented accuracy. This isn't just about pretty pictures, it's about saving lives and money. Imagine knowing precisely where to build new infrastructure, avoiding underground pipes and cables. This technology captures 1 billion data points, creating a living, breathing model of our urban environments. It's a paradigm shift from guesswork to data-driven design, meaning no more cities built in the dark. By 2015, over 30 cities had embraced 3D mapping, a massive upgrade from manual surveys that once took weeks for a single block. This wasn't a sudden leap, but a deliberate shift. Urban planners, fed up with the limits of flat maps, really wanted a richer digital view. They needed incredibly accurate data to assess infrastructure. Those old 2D maps held only 5% of the detail now essential for running a city. Think about trying to plan something intricate using just a few puzzle pieces. Planners dreamed of a digital twin, a living, breathing copy of the city, complete with every structure and pipe. This grand vision propelled the move to advanced aerial mapping. One immediate win was better energy efficiency. 3D models can predict solar exposure with 98% accuracy, drastically cutting energy use. That's like knowing precisely where to place solar panels for peak performance every single time. Collision risks for new construction projects plummeted by 75%. Planners could virtually test out bridges or new subway lines before any actual digging began. Flood simulation models, leveraging 3D terrain data, became accurate to within 5 centimeters. What used to take months of groundwork was accomplished in hours from the sky. A medium-sized city could be mapped in just 2 days. A whole new industry blossomed, growing 15% yearly, and creating jobs like lidar data analysts. It's akin to moving from a napkin sketch to a hyper-realistic CAD design. Governments quickly updated rules, setting data standards for these new city models. This tech boom wasn't just about more data. It fundamentally changed how we envision and run cities, paving the way for more resilient, efficient futures. 500,000 data points captured every second. That's how modern aerial lidar systems now map our cities. Each laser pulse precisely measures distance, rendering urban landscapes with building-level accuracy down to 2 centimeters. This technology can transform entire metropolises into incredibly detailed digital twins, faster than you can blink. The ambition was monumental, to create a digital replica of the urban environment, point by painstaking point. An average urban survey using this tech can collect over 1 billion data points in a single flight. To put that in perspective, just 1 hour of lidar scanning can generate roughly the same amount of data as 1,000 high-resolution satellite images. This isn't just about creating pretty models, though. This data is actually used for critical infrastructure planning. For instance, detecting minute changes in road surfaces can predict maintenance needs years in advance, saving millions in emergency repairs. Identifying the exact location and height of every single tree in a city helps urban foresters plan for canopy expansion and wildfire mitigation. Even subtle variations in building facades can inform seismic retrofitting strategies. The sheer volume of data, though, requires immense processing power. Specialized software algorithms analyze these point clouds, filtering out noise and categorizing objects like trees, buildings, power lines, and vehicles. This is where the engineering marvel truly lies, not just in capturing the data, but in making it usable for decision makers. A single urban block's digital twin can contain petabytes of information, requiring advanced cloud computing for analysis and visualization. What happens when a city embraces this level of digital detail? Plans for new subway lines can be optimized to avoid existing underground utilities with centimeter-level precision. Cities are now designing with over 1 billion data points guiding their every move, acting as a sophisticated urban blueprint. This isn't just a map, it's a living prediction engine, simulating future growth with 95% accuracy. Old planning felt like sketching a 50-story skyscraper with crayons, which is why 30% of projects back then needed major rework. But now, thanks to 3D mapping that captures data down to the centimeter, those kinds of errors are dramatically reduced. Planners are optimizing infrastructure, cutting material waste by 15% and shaving 25% off development time. Consider a single 3D London model packed with over 1 billion data points. That's more information than 50,000 architectural blueprints. This incredible detail directly impacts budgets, leading to 10% lower costs on projects in cities like Singapore. Public engagement gets a boost too. Interactive 3D models increase citizen feedback by 30%, building better community buy-in. Environmental modeling uses this data to optimize green spaces, potentially lowering urban heat island effects by 2 degrees Celsius. Beyond planning, 3D mapping even helps disaster preparedness, simulating flood risks and mapping emergency routes in under 5 minutes. We've essentially gone from glorified paper guesswork to engineering urban futures with digital DNA. While evolution built cities through millennia of trial and error, we now possess a digital crystal ball. Future smart cities will deploy these dynamic models for real-time traffic management, automated waste collection, and energy grid optimization, slashing operational costs by 20%.